Hi, my name is Galina Alperovich. In this video, I will show my final project on Big Data Analytics course in Harvard University Extension School. The topic of my project is Cassandra and Time Series. My project consists of two parts. First one is theoretical part. I will tell why Cassandra NoSQL database is very good choice for time series data. I will tell you how Cassandra stores the data and what kind of limitation it has. I will tell about primary partition and clustering key, what it is, how to work with this, and I will show example of working with the keys with financial time series data. As a practical part of my project, I developed web application which analyze and visualize stock data. I use Cassandra for storing the data. Here you can see the screenshot. So, time series is a data points indexed on time order. So for time series data, you must have timestamp and some numeric value. You probably know a lot of examples of such data. For example, logs, sensors data, some financial indicators, performance metrics, user activity, and so on. There are some particular properties of time series data. First of all, usually it's growing very fast, so it's big data, because for every timestamp, you have a new value. Also, data points are related to each other, because today's value is usually related with the previous values, previous data types. Also, usually with the time series data, we select the data by the key and then by the time range. What I want to say is that Cassandra NoSQL database is really very good match for these requirements. First of all, Cassandra database uses the clusters of nodes, and it's very scalable. It's easy to add new nodes, and the writing and reading performance is growing linearly when you add new nodes. Also, it has automatic replication of data, so your data is safe. Cassandra NoSQL has no single point of failure. It means if some node fails, the entire system won't stop. And it's very good property, so it has high availability. Also, Cassandra database can perform millions of write and read operations per second. Also, it has SQL language, which is very familiar to you because it's very similar to SQL. But the disadvantages of Cassandra NoSQL and all other NoSQL databases, that's because it's very different from SQL. There is no familiar aggregation method, some ad hoc queries, no complicated columns manipulation, because it's key-value storage and it uses different model. So Cassandra is very good for some specific use cases, for example for time series, for some sequential data. But in general case, you need to think, well, what to use, what kind of database to use. Maybe it's better to use SQL database. Cassandra is used by many companies. Here you can see some famous companies. On this picture, you see the classic table, how we usually imagine time series data. So you have three columns, for example, symbol ID, timestamp, and closing price. For every symbol ID, for example, Apple or Google, etc., and for every timestamp, in such case, is daily data. You have some value, for example, closing price. So it's important to know that Cassandra stores the table in a different way, not like this. And I will explain how. For example, we want to create such table. We will create table stocks with three columns: symbol ID, event time, and closing price. We will set this primary key, symbol ID and event time. I will explain a little bit later what does it mean. After this query, we will get this kind of table. For every row, we will have one specific symbol. That means all data for Apple stocks will be stored in one row, and for every column we have different timestamps. Again, The Google stocks will be stored in a different row, and for every timestamps we have different columns. Rows are independent, so timestamps can be different for different rows. But what if we have data every second? That means we will have a lot of columns. For such table, Cassandra has a limitation. It might have only 2 billions of columns. In case of seconds, we will exceed this limit. To select the data, you need to perform this query. It looks very similar to SQL. If we exceed the limit of columns, we can use partitioning. To perform partitioning, we need to create additional data column. For example, date. So we will create table stocks with 4 columns: symbol ID, date, event time, and closing price. And we will set primary key in this way. We will add date to this part of primary key. In this case, we will have a row for every pair symbol ID and date. For example, Apple for this date, Apple for this date, and for every date we have columns of the time. That means if you want to use, for example, data for every milliseconds, you can use partition by 3 columns: symbol ID, date, and for example hour. And in every column you will have second or milliseconds. To select the data, you execute similar queries, but you specify symbol ID, you specify date, and range. This process is called partitioning. There is a rule that we can have maximum 2 billion number of cells, means rows times columns, for one partition. Let's discuss in detail what is primary key. So all this statement is a primary key. It consists of 2 parts. It's partition key and clustering key. Partition key is the first element of primary key. It might be one column, for example, symbol ID, or it might be 2 columns or more, symbol ID, date, etc. Cassandra used partition key to distribute data across nodes. Cassandra calculates the hash function of the partition key and then puts the record to the node. For every node, there is a specific range of the hash values. For example, if we have 4 nodes, we can say that the data with the hash value between 1 and 25 will be stored on the node number 1. From 26 to 50 will be stored on node number 2, and so on. So partition key is distributing the data across nodes. This is a clustering key. All other elements in the primary key is a clustering key, but it's always single one. So not pairs as in a partition key. Clustering key is responsible for sorting data within the partition. By default, the data is sorted in ascending order, but you can change it when create the table. Let's consider this query. We create table stocks with 4 columns: symbol ID, date, event time, and closing price. We use this primary key. We use symbol ID and date as a partition key. We use event time as a clustering key. And we change the order to descending one. Now I will tell you about the practical part of my project. I developed the web application. I wrote it in Python. And I used Cassandra NoSQL database on backend. I used open wiki databases of the stock prices for the last 40 years. I took it from popular service Quandl. I used Bokeh library for interactive plots. The features I developed includes visualization of time series, summary statistics, original data table, and ability to aggregate daily data monthly, quarterly, and annually. The main feature is forecasting. I do it with the library Profe, which is recently open sourced by Facebook. In my report, I wrote the step-by-step guide how to create such project from very beginning to deployment to AWS. That's how it looks like. The application is available by this URL, and the source code is available on this GitHub repo. That's the application. First of all, we need to select the company name. As we can see, the time series on the graph is changing. Then we can choose some indicator. For example, we can choose adjusting lower price. Also, we can aggregate the data, for example, monthly. We see the summary statistics for this data: mean, standard deviation, minimum, maximum, and quartiles. Also, we see original data for the company. We can sort the data. We can see some specific values. If we click on Predict button, we'll see the forecast together with the confidence interval. It's also called the corridor. We can use interactive bokeh widget in order to work with data closely. For example, we can zoom and navigate. Let's choose another company, for example, eBay. We see that the stock price is decreasing for the last decades. Let's aggregate data annually. Let's predict it. We see that unfortunately it's decreasing. So that's basically my web application. As I said, I used OpenWiki database of 3,000 US companies from Quandl Web Service. I used interactive bokeh library for Python. I use Cassandra and NoSQL database on backend and Python language for the server. Thank you for your attention.